Good afternoon, my YouTube viewers. In this video, what we're going to talk about is the chi-square distribution. So the chi-square distribution is positively skewed and it's used in tests involving variance or categorical data. And then so what we're going to do is we're going to perform a hypothesis test using a chi-square distribution just to give you some insight into how to do it. So in this hypothesis test, we're going to test whether the observed proportions of voters by political party match the expected proportions in an election. And so we're going to create a Python program to perform this test. And in order to create the Python program, the first thing that we're going to have to do is import the libraries that we're going to need to execute the program. So we're going to import NumPy as NP, which is the numeric library, and we're going to import scipy.stats as stats. And stats is the statistical module of the scipy library, and scipy is Python's scientific library. And then we're going to import matplotlib.pyplot as PLT. And then what we're going to do is we're going to define our data. So we've got the observed data is NP array, a NumPy array of a list of 50, 30, and 20. So that's party A, party B, and party C. And then so we're going to define the expected proportions based on historical data or predictions. And so it's going to, the predicted proportions are going to be example of 40%, 40%, and 20%. So the expected proportions are a NumPy array of a list of 0.4, 0.4, 0.2 to give you 40%, 40%, and 20%. And the total observed is the sum of the observed. So it should be 100 because 50, 30, and 20 is 100. And expected is the expected proportions plus times, I believe. I can't see very well just with my glasses. I think it's times total observed. And then now we're going to perform a chi-square goodness of fit test. So chi-square stat, comma, p-value equals stats dot chi-square brackets f observed equals observed, comma, f exp equals expected. So you're going to it's going to take the observed values and the expected values as arguments to the function. So now we're going to print the results. So we're going to print the chi-square test statistic and the p-value. So your chi-square statistic is 5 and your p-value is 0.821. And since the p-value is greater than 0.05, then you're going to fail to reject the null hypothesis, as there's no significant difference between the observed proportions and the matched proportions. And it says the observed proportions match the expected proportions. So there's no significant difference between the two. So we come back up here and it says if your p-value is less than 0.05, then you reject the null hypothesis. But it wasn't less than 0.05, it was greater than 0.05. So we failed to reject the null hypothesis. And then so now what we're going to do is we're going to visualize the data. So we're going to create a bar plot of the observed versus the expected frequencies. So category is a list of party A, party B, and party C, and X is np.arrange len categories, and the length of categories is 3. So now we're going to create a chart, plt.figure brackets fig size equals 6, 4. And then we're going to plot the observed and expected frequencies with a bar chart. PLT dot bar brackets x minus 0.2, comma, observed, comma, width equals 0.4, comma, label equals observed, comma, color equals blue, comma, alpha equals 0.7. And then you have PLT dot bar brackets x plus 0.2, comma, expected, comma, width equals 0.4, comma, label equals expected, comma, color equals orange, comma, alpha equals 0.7. And so now we're going to add labels, title, and a legend to your chart. So we're going to have X ticks, PLT.X ticks, brackets X, comma, categories. The title is Observed versus Expected Voter Proportions. X label is political party. Y label is number of voters. And then you get a legend, and your grid is axis equals Y, comma, line style equals dash, comma, alpha equals 0.7. And then we show it. So this is the chart that's been created. It's observed versus expected voter proportions. So party A, the observed proportions are greater than the expected proportions. And then party B, the expected proportions are greater than the observed proportions. And party C, the observed proportions and the expected proportions are the same. But even though there are variances in the proportions of party A and party B, it still was not enough to cause the hypothesis test to reject the null hypothesis, because the p-value is 0.0821, and in order for it to reject the null hypothesis, it had to be 0.05, which it wasn't. So that concludes this video. In the next video, we're going to be talking about an F distribution, and I hope that you decide to watch it.